Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. So this is video number 61 for your 60 out of 16 KCET Mathematics in 100-day series. Okay, so we are dealing with the last session for the probability, which is the session number 3. Okay, dealing with Bayes Theorem. Okay, so we'll see again the concepts, the statement, the formulas, why we need it, all of that will be discussed in the session today. And again, I've taken 10 questions which I'll solve in the session today, and I'll give you one homework as well. So homework, learning the concepts, and solving the questions. Okay, so this will be the complete package for this particular topic, Bayes Theorem. Let's look at the concept now. So why do we need this? Okay, for example, whenever we are asked to find the reverse probability, okay, means for an event that already occurred, we're trying to relate with that, okay, and trying to reach to the probability of a event that can occur after that. Okay, means for example, if I ask you a simple question, find the probability of getting white ball from bag 1. Simple problem, right? We can find choosing bag 1 is half and half, sir. Bag 1 you can choose like two identical bags, no? So half probability is this, half probability of that. Okay, choosing a bag 1 is what's the probability? Half, right? 50%. Same goes with bag 2. Now if I'm asking you to pick a white ball from bag 1, you can find the total number of white balls and total number of balls and find the probability, okay, with the intersection, right? That's very simple. You can do that again. But if somebody is asking you for a situation where I have already chosen a white ball, find the probability that it is from the bag 1. I'll repeat, I already have chosen a white ball, means I have already picked the white ball out of the bag. You have to find the probability that it is going to be from bag 1 or bag 2, whatever is the question, okay? So you might think that, sir, haven't we dealt with this in the conditional probability? Yes, bacha, we have dealt with the problem like this in the conditional probability. Actually, we can say this theorem is nothing but, application or next step to the conditional probability. Correct, na? So, but we are dealing with multiple events over here. When you see the questions, you'll understand that. So Bayes theorem, when is required, whenever we're dealing with the reverse probability, means from the event that is occurring right now, we try to consider the event that has already occurred. Similar to what we learned in conditional probability, nothing different. Now have a look. To learn the formula in the Bayes theorem, we have to know few things. One thing is partition of a sample space, another thing is total probability. Okay, so let's just learn this part first. Partition of a sample space means if I have a sample space S given like this, chaliye, and I try to create a partition in the sample space in this fashion. So let's say this is the event 1, the first partition, the partition number 2, E2, partition number 3, okay, partition number 4, partition number 5, and so on. We also have here En bacha, means we have total of n partitions, E1, E2, E3 till En is said to be the partition of the sample space S, okay. Then this partition has to uphold certain conditions to be called this partition of a sample space. Means for this E1, E2, E3 up to En to be called sample space partition, it has to uphold certain conditions. The first one is bacha, that E1 intersection with E2 should always be equal to null value. Means nothing should be common between them. So intersection between them has to be null. So if I have to define it, in the standard form, in general form, I can write like this: EI intersection with EJ should always be equal to null value. Whereas what is I and J, bacha? I comma J is nothing but the values 1, 2, 3 up to n. So the event values, na E1, E2, E3. So I and J are nothing but the values 1, 2, 3 up to n. The first condition is this. Second condition, bacha, is that if you take the union of all of this, E1 to E2 to E3 all the way to En, okay, the answer should be always sample space. Okay, if you take union of all these partitions, the resulting has to be always sample space. And the last one, very important, probability of any of these events must be always non-zero, or has to be always greater than 0, bacha, always non-zero. So if I have to combine all these conditions, okay, in statement wise, why important is statement wise? Because they ask in MCQs, bacha, that's why. Okay, they can ask in boards as well, they can ask in KCET as well. Okay, so the conditions will become, okay, pairwise disjoint means the partitions that you're seeing E1, E2, E3 up to En has to be pairwise disjoint. Okay, next what, bacha? Next has to be exhaustive in nature. in nature. And the last one, very important, what bacha? Should have non-zero probabilities. Should have non-zero probabilities. These are the conditions that these partitions E1 to En has to uphold to be able to call what? The partition of the sample space S. I hope this is clear. Chaliye, please have a look. Okay, this is the understanding of bacha, the partitions. Okay, 3 conditions, again in the words also I've written. Pairwise disjoint, exhaustive and non-zero probability. Very, very important. Okay, now we'll look at theorem of total probability. Means we have the partitions now in the sample space E1, E2, E3, so on till En. Okay, and there's an event A. There's an event A in the sample space. Okay, let's read it. Let E1, E2, E3 be the partition of the sample space S, and A be any event associated with the sample space S. Then the probability of the event A, okay, total probability of the event A is given by, what is this? This whole statement bacha, or also this form. Sir, looks confusing, sir. Can you simplify this? Of course I will. Don't worry. So if you are able to find this statement confusing, I can write one thing and you will understand for sure what I mean by this statement. Okay, we'll again make use of conditional probability. You can see this. These are all what bacha? Conditional probabilities only, no? Yes, sir. So P of A would be given by probability of the event A intersection with the partition number 1. Same thing bacha with the partition number 2. Probability of the event A intersection with the partition number 2, and so on till probability of the event A intersection with partition number N. Okay. Now if I have to define this, if you remember, probability of the event A when that E1 has already occurred, okay, the conditional probability is given by what bacha? PA intersection E1 divided by PE1, na? Right? Definition of the conditional probability. Cross multiply this. What we are getting, sir? We are getting, sir, PE1 product with P conditional AE1, okay, is equals to PA intersection E1. Check this out. From here, PA intersection E1 can be written as PE1 times PAE1. From where, sir? From the definition of conditional probability. If I use this bacha over here, I get what? Check this out. I get what? For this thing, I can write this PA as first one. This thing PA intersection with the event E1 with the partition E1 will get as simply this statement: P of E1 times, okay, P of A E1. Same thing is written over here. Have a look. PE1 dot PAE1. Same thing is written there, bacha. Right or not? Same way I can write this for second one. PA intersection with E2 can be written as PE2 times PAE2, the conditional probability. Same goes till nth term as well. So PEN times P conditional probability of AEN. Okay, chaliye. So same thing. No, this is the general form. Summation of all these probabilities for the ith event. Check this out. EI 1, 2, 3 can be called as EI P of A, provided that EI has already occurred. I from where to where? From 0 to n. From 0 to n. I hope this is clear. Please have a look. This is the way to write total probability for any given event. Very, very important. How do we get this? From the intersection only. So we're going to use this a lot. Okay, we're going to use this a lot in the questions where we have to solve what? Using Bayes theorem. If you see the formula now, you'll get to know. Have a look. What is this part, sir? This is nothing but total probability only, no, sir? Total probability. 1 second. Total probability of the event A, sir. Okay, probability of event, check here, A, of event A. Same thing is written over here. PA, check this out. PA, summation of E per EI to 0, PEI dot PAEI, for I belonging to 1, 2, 3 to n. Okay, what about this, sir? That's what is this, bacha? Is it confusing, sir? Is it confusing, bacha? Of course not. What is this? Simple definition of conditional probability. So that's what I'm telling you. You can write the Bayes theorem with the help of what? Conditional probability only. It's basically a new application, a next step to the conditional probability. EI, provided that A has already occurred, is given by E intersection with the A divided by PA. PEI can be written again with the help of conditional probability. Over here, have a look. PA, provided that E of I has already occurred. Okay, chaliye. This is very, very important. Don't worry, it looks confusing over here, but when you start solving problems, no, things will become very, very simple. Okay, chaliye, have a look. If you want, I can read this statement for you. If E1, E2, E3, En are mutually exclusive and exhaustive events. Definition is very important, right? Because they have to be creating the partition in the sample space. Okay, associated with the random experiment A. Okay, and A is any event associated with the experiment. Okay, then I can define this probability this way. Bayes theorem is, this is the formula, bacha. This is the formula, sir. Very, 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 very important. I'll break this formula, don't worry. I'll break this formula in the simplest possible way when I'm solving the questions. Don't worry. Okay, so let's look at the problems now. 1/3 of the students of a class are boys and the rest are girls. Okay, it is known that the probability of a girl getting a first class marks in board exam is 0.6. So let's highlight the numbers. Very important for us. 1/3 are boys. Have a look. 1/3 are boys and rest means what, bacha? Rest means 2/3, na? Rest means 2/3. 1/3 of boy means rest is 2/3. Okay, okay, and okay, so first class score by a girl is given by 0.6. Probability is given like that, and first class score by a boy is given with probability of 0.35. Find the probability that a student chosen at random will get first class marks. So basically they are asking about probability of getting first class marks. First class mark, I call this like this, no? They're asking what? Let's say if I associate the variable f as a student getting first class mark. First class marks. Okay, so if I call this to be the event f, okay, the event is defined with the variable f, then that's what they're asking. PF they're asking, bacha. So to look for all the cases, PF with girl and boy. Okay, so let's have a look. Probability of the event f when we're talking about, let's say, boys. Okay, what is it, sir? Probability of that student is the boy. Okay, provided that is getting the score correct. No, which one, sir? It's a boy and getting first class marks. First class marks. Okay, it's a boy and getting a first class marks. Okay, plus same way, bacha, for a girl and getting a first class marks. Chari, they've given you this value. PB is what, bacha? PV is given as 1/3, na? So I have here 1/3. For this I have the probability is 0.35. Let's write it here, 0.35 plus for the girl we have 2/3. Probability of getting a girl. Okay, to choose a girl we have, what is the probability? 2/3, right? And for girl to get the first class marks is 0.6. I can take something common, right? I can take 1/3 common here. Okay, this becomes 0.35 plus 1.2, right? 0.6 into 2 is 1.2. I can add this, it'll become 1/3 times of, how much is this? 1.55, है ना? So my answer finally will become this. Have a look. 1.55 divided by 300, na? Right? 300, right? Okay. So I can take it like this. 3 with 1 second. 1.55. Okay. It'll become, bacha, what, sir? Check this out. I can cancel with 5, no? So I can write this as, okay, 1 second. Well, I can do better. I don't have to cancel it like this. I can write, okay, 1 second. Give me just a second. Okay. Yeah, I can write it like this, 3 into 100 only. That's better. Now you can divide this by 5. Both of them. 5 2s are 10. Then 0 will come. 5 3s are 15. And 5 1s are 1. Right? I'm getting this as 31/60. Could have divided that way as well, but this is also okay. Answer is 31/60. Please check. What is this answer for? Probability of getting a student from which category? first class marks. Okay, student getting first class marks. I've taken the event as F. Probability of what is B means, bacha? For the chosen, the boy is the girl, student chosen as boy, and G is what? Student chosen is a girl. Okay, chaliye. This is the answer for first one. Are we using here, sir, Bayes theorem? No, bacha, we are not using directly. We're just writing it for total probability. Correct, na? Total probability. Have a look. Question number 1 is done. Okay. You got it, no? How I got 2 by 3, right? 1/3 is the number of students who are boys. So girl will be what, bacha? The girl will be, of course, 2 by 3, no? 2 by 3. Boys are 1 by 3, no? The strength is 1 by 3, means girl has to be 2 by 3 only. Have a look. Okay, chaliye, let's move on to question number 2. In a factory which manufactures bowls, machine A, B, C manufactures respectively. Okay, great. Means there are 3 machines here, A, B, C. They have taken the classification as first machine manufacture 25% of the strength, second is 35%, and the last is 40% of the total production of the bolts. Okay, of their output, 5, 4 and 2% are defective. Same way, A is having 5% defective, B is having 4% defective, and C is having 2% defective. Okay, the bolts are defective like this. A bolt is drawn at random from the product and is found to be defective. Okay, what is the probability that it is manufactured by machine B? This is going to be using what? The Bayes theorem only. Have a look. So basically, bacha, what they are asking is probability of getting a bolt from machine B, provided that is defective. Means it is defective already, and we have to choose that from where, bacha? Defective piece I have chosen, but it has to be from which one? From the machine number B. You can see this, no? We are trying to retrace back the probability. Okay, reverse the probability. Okay, so for that they are looking for the answer. So how will they write this, bacha? The formula will be written for this, bacha. Will be like this. Have a look. Probability of bolt, defective bolt from machine B is given by, check this out, probability of, okay, intersection P, B intersection D divided by, okay, means it has to be from the bolt, from the machine B and defective, divided by what, bacha? Total probability of P, defective probability. Correct, na? PD, right? Okay, chaliye. Now if I am writing this, bacha, this is from the help of conditional probability, but we can write direct formula also. Okay, what is the direct formula? Have a look. This can become simply P D times of P, okay, 1 second. Yes, just a second. So this will become, bacha, PB times of PDB. Correct, now? Means from the machine B which is defective. Okay, like that. How we are writing this? From this definition, no? PDB will be given by intersection by PB. This one, bacha. Probability of the machine, so from the machine B we are getting defective piece will be given by this, no? D intersection B divided by PB. So cross multiply these two. So the intersection will become what, bacha? P times PDB. PB times PDB. Okay, chaliye. This is the first part divided by. You have to write for the all machines. Okay, so first we'll write over here. Have a look. For the machine A, means the defective piece from machine A will be given like this. Defective piece from machine A will be given like this. Same will go with the machine B. So defective piece from the machine B, and plus last one, defective piece from the machine C. Don't worry, I explained this to you, the entire formula. Okay, probability of choosing the machine A, the defective piece is coming from the machine A, defective piece is coming from the machine B, and defective piece is coming from the machine C. Let's look at the values that we have. Okay, chaliye. So PD is given by probability of getting machine B is what, bacha? Is 0.35. No, 35% is there, right? For machine B, it means 0.35 multiplied with that is going to be defective. Defective, what is that, sir? For machine B, 4. It means, sir, 0.04, sir. 0.04, sir. Great, bacha. Divided by this one. PA is 0.25. PA is 0.25 multiplied with 0.05. PA, choosing the machine A is what, bacha? the bolt coming from machine A is what? 25%, no? The total production out of the bolt is, the machine A's contribution is what? 25%. Means if I choose a bolt coming out of machine A, the chances are getting 1 by 4. So 0.25 multiplied with defective condition from the bolt A. Okay, so from the machine A, the bolt is defective. Chances are 5%, so 0.05. Same goes with other machines as well. So PV will be same thing, 0.35 times 0.04. The last one is PC. Okay, we'll have 0.4 times what bacha will be 0.02. Okay, chaliye, let's have a look at this value. Okay, what are we getting over here? So if I multiply all of this, I'm going to get 5 4s are 20. Okay, and 4 is a 12 plus 2 will be 14, right? We have total of 4 decimal places, so 0.014. Have a look. 5 4 is 20, carry is 2. 5 3 4 is 12 plus 2 is 14. This is the answer for the numerator. What about denominator, sir? 25 times 5 is 125. 4 places, right? So I'm going to write this as 0.0125. Okay, check this out now. 2 decimal place here, 2 decimal place over there. So 4 decimal places, right? Over here also same thing. This is the same value, 0.014. Okay, plus the last one, 4 2s are 8, right? 4 2s are 8, and there are 3 decimal places, so 0.008. Okay, so let's have a look for the final answer. PBD. Already that the machine, the defective piece is coming from the machine B. It's giving from, what is it, 0.014. 0.014 divided by, what is it, sir? 0.0125. 0.0125 plus 0.014 plus 0.008. है ना? Have a look one last time. Yeah, everything is right. 0.0125, 0.014 and 008. Okay, chaliye, let's add all of this. What I'm getting here, 0.014 divided by, add all of this. So if you take this over here, you're gonna get 5. The last is 5, no? So 5 will be as it is. 8 plus 4 is 12, plus 2 is 14, carry is 1. Okay, next is what, sir? I have 0 over here, so 1 plus 1 is 2, plus 2 is 4. Again I have 0 over here. Okay, no, one second, there's a mistake. I've taken 2 times. I've taken 2 times. Okay, so last is going to be 5. Of course, we have 0 over here, 0 over there. This is what, sir? 8 plus 1. So 8 plus 4 is 12, plus 2 is 14, carry is 1. Then 1 plus 0 is going to be 1 only, plus 0. And we have again here. So I can write this 0 over here. This also has 0, this also is 0. Let's add it, will be easier, bacha. Why bacha is easier? 4 decimal places, that's the reason. Okay, so I'm getting 0.140 divided by, first 5 zeros, this will be 5 only. We have 8 plus 4, 12 plus 2 is 14, carry is 1. 1 plus 1 is 2, plus 1 is 3. There's a 0 over here. Okay, again 0.0345. I can cancel this out. What I'm getting, 140 by 345. Cancel with 5, sir. What are we getting, bacha, here? 5 2s are 10, 4 is there, no? 5 8s are 40. 5 6s are 30. We have 4, so 5 9s are 45. What is my answer? Probability of getting the defective piece from the machine B is coming as 28 by 69. 28 by 69. Please have a look. Okay, 5 6 are 30 and 5 9s are 45. Correct, sir. This is correct. This is the answer. We are looking for this value only. No? P, B, conditional probability D. Okay, please have a look. Right? Everything looks right. If you're getting a different answer, let me know in the comment section. But I think this is correct. Please have a look. I'll start with the question number 3. This is okay. Question number 3 now. Chali. A man is known to speak truth 3 out of 4 times. He throws a die and reports that it is a 6. Find the probability that it is actually a 6. Okay. Chaliye. So let's say that probability of that. Okay. 1 second. I'm going to define the events, bacha, first. So let's say there are 2 cases, no? First case is event number 1. Okay. Event number 1 where we are actually after throw, no, we are getting the 6. Okay. Means probability of event E1 is given as for getting a 6. Okay. and event E2 is where not getting a 6. Means when the die is thrown, we are not getting a 6. Okay, that's the two probabilities. E1 means when the die is thrown, we are getting a 6. E2 means when the die is thrown, we are not getting a 6. Okay, chaliye. So not getting a 6, E1 and E2. Great. He throws a die. Now, what is reports? That a man reports that it is a 6. Okay, now think about it. Man reports, what are you looking for? Probability of actually a 6. Okay, means we are looking for E1, whatever he has reported, it has to be, 1 second, this is the question, bacha. Probability that it is actually a 6. Okay, 6 means event E1, whatever is reported, means he has given some report and that report is true. That is what we are looking for. Okay, so probability of the event E1 when the report is given by the man. Okay, we are looking for this value. So for this, bacha, we have to find this value. So we can write this as probability of event E1. Okay, conditional probability that R is already occurred will be given by, I can write directly now, na? So we can write like this, PR E1 times E1, no? Probability of event E1. Now I can write what, divided by the conditional probability, sorry, the total probability of all both the events. Same way, event E1 PR E1, okay, plus probability of the event E2 and PR E2. Don't worry, I'll define it. Okay, so event that means whatever his report is true. What is the case, bacha? Reports, whatever he reports and that is true, means he's getting a 6, means what is the answer? 3/4. Okay, what about this? He reports and it is not coming as 6. What is the answer, bacha? 1/4, means he's lying. He reports it is a 6. What is R? Man reports that it is a 6, but it is actually what? E2. What is E2? Not getting a 6, means he is lying, right? So 1/4, speaks truth 3 out of 4 times. So lies 1/4 time. Okay, what about E1 and E2? So E1 is simple, sir, 1/6, and this is about 5/6. Not getting a 6 is what? 2, 3, 4, 5. Sorry, 1, 2, 3, 4, 5. And getting a 6 is what? Only 6. Okay, so 1/6 and 5/6 is the probability of E1 and E2. Like this. Okay, let's use it over here. So we can write this as 3/4 times of 1/6 divided by 3/4 times of, again same thing, 1/6 plus 1/4 times of 5/6. Have a look. Okay, so I can write like this, the final answer over here. This will be given by, bacha, probability that actually is 6 after whatever he reported, okay, will be coming as 3/6 into 4, so 24 divided by 3/24 plus 5/24. What is this going to be? 3/24 upon 8/24. 24 gone. What is the answer? 3/8, sir. This is the probability of that it is actually a 6 over whatever he has reported. Whatever he has reported, it is actually a 6. So 3/8. What is the report, sir? That man report that it is a 6. That it is a 6. Please have a look. The answer is 3/8. Question number 3 is done. I hope this is clear. Okay. Interesting topic. Actually interesting. This is a little bit confusing, but I hope you find this easier now. Okay. Just remember this. If you're not able to, crack this at all, do one thing. Just stick to the conditional probability. Stick to the conditional probability. You can write this. You don't have to write this formula all the time. This is the formula from Bayes theorem. You can use conditional probability. That way, the way I used in the second question. Have a look. I did not use this. I used the formula from where, bacha? From the conditional probability and got the result. Same thing will come. If you're not able to make use of Bayes theorem, you can use that previous one also. Okay. Please have a look. Question number 3 is done. Moving to question number 4. A purse contains 2 silver and 4 copper coins. A second purse contains 4 silver and 3 copper coins. If a coin is pulled at random from one of the 2 purses, what is the probability that it is a silver coin? Okay, so basically they are asking what to find this. They are asking us this value, no? Probability of getting a silver coin. What is the probability that it is a silver coin from wherever it is pulled? Okay, so we are asking what? Probability of silver coin. We have to check again conditional probability of that silver coin from the purse 1 and silver coin from the purse 2. We'll have to look into that. But right now, understand this is the question. What's the question, sir? Probability of getting a silver coin. That's the question. Okay. Means what we have to make use of? Bayes theorem? No, we have to make use of total probability. That's all. Chaliye. So let's have a look. From purse 1, let's call it to be purse number purse A and purse, sorry, one second, purse B. Purse B. Chaliye. So we are looking to get what, bacha? Picking of these two purses will be what, sir? P of A would be 1 by 2 and P of B would be again 1 by 2. Okay, now picking a silver coin, right? So picking a silver from the purse A would be given by what, bacha? Would be given by, check this out, 2 by 6, sir. 2 by 6, na? 2 and 4 is there, right? Total is 6, so 2 by 6. And picking a silver from the purse number 2 of B is given as, what is it, sir? 3 by, so 4 by 7. 4 is silver, 3 is copper, so 4 by 7. Correct, na? Okay, chaliye. So picking a silver from purse B and picking a silver from purse number A. We're looking for this value PS. We know this value PS is given by, have a look, P of A, okay, times P of SA, है ना? Same way over here, बच्चा. P of B times P of SP, right? So this makes the answer 1 by 2 and 2 by 6 plus 1 by 2 times 4 by 7. Okay, I can take 1 by 2 common, right? Let's have a look. I can take 1 by 2 common, so my PS will become, check this out, 2 by 6 I have plus 4 by 7. Let's take LCM and simplify this. Okay, LCM is 42. 6 and 7 LCM is 42, right? Not a problem. So 7 2s are 14 and I have a 7 6, so 6 4s are 24. So if I have to cancel with 2, right, it'll become, bacha, what is it? 2 times, it'll become 7, it'll become 12, right? So 42, what is the answer? 19 by 42. Option number C is correct. Option number C is correct. Please have a look. 19 by 42 is the right answer. Correct, no? You got this part, right? 2 I'm dividing with both the terms, right? Denominator over here, numerator over here, I can cancel both the terms. 2 times 7 is 14, 2 times 12 is 24. Then adding them together, getting the answer as 19 by 42. Simple question. Okay, not use of Bayes theorem, only the total probability. Chaliye. Please have a look. I'm going to move on to question number 5 now. 1/2% of the population has a particular disease. Okay, a test is developed for the disease. The test gives a false positive 3% of a time and a false negative 2% of the time. Means false negative means what? Let's say a person is positive and gives us what, bacha? Negative, means that's false, right? The wrong result. So 2% negative. Okay, and false positive means a person is not having the disease and gives us what's a positive, means false positive. Not having, false positive, having, false negative. So that's the error. Correct, now? What is the meaning of the error? I am, let's say, positive and they're giving what? False negative, that's error, right? I'm positive, I'm giving false negative, that's the error. What is the error for me? 2%. If somebody is not positive, okay, and they're giving what? False positive, means 3% is the error, bacha. For a person who is not affected with the disease, error is what? False positive. For a person which is affected with the disease, the error is what? False negative. I hope this is clear, na? Chaliye. What is the probability that Amit tests positive, a random person? What is that I was looking for? Probability that a person has, the test is, okay, let's define the variable first. T is what? Amit tests positive. They're asking what, bacha? PT is equals to how much? Probability that Amit tests positive. What is the T, bacha? T is the event where Amit tests positive. Okay, chaliye. So let's look for something now. Let's say person who is having a disease is testing and having what? The disease. Getting the test done and having disease. Okay, chaliye. So yeah, correct, bacha. So getting the test done and having the disease. What does it mean? Having the disease, right, means it has to be positive. What is it saying? 2% time it is giving us false negative, means that's the condition we have to use. So 0.9, think about it. Person who is testing and having the disease should come what, bacha? Should come positive, no? But they are getting what? 2 false negative. So we have to include the error also. So if you remove the error, what is it? 98% the test will come. Give me the desirable outcome. So 0.9%, 0.898 is that. 98% is what? 0.98. Same way, probability that there's a test conducted, okay, and person is not having disease and test is conducted giving that positive. I'll repeat. Having disease and test positive. Having disease, test positive. Okay. What's the chances? 98%. How come, sir? No, why not 100%? Having disease, test positive. Because 2% chances are there, no, that will give you a false negative also, right? Having disease, test positive. 2% chances are there, that will give me false negative. Having not disease means I'm not going to have the disease, still test positive. What is T, sir? T is that Amit test positive. Not having the disease. D dash means what? D means, let's say, D is the, okay, person has the disease. Person is affected with the disease. With disease. Okay. So D dash means what? Not affected. So person is not affected with the disease, still comes positive. A person not affected with the disease, still come positive. Sir, false positive, sir, 3%. No, bacha. 3%, basically, sir, 0.003. I hope this is clear. Person who is having the disease and test positive. Sir, answer would be 100%. Having the disease and test positive. But they are giving no. The equipment has a error. False negative 2% they are giving, bacha. That's why we have to remove that 0.02. Okay, that's why it is 0.98, not 1. It's 0.98. What about this, sir? Not positive, not having the disease, still getting positive. It means the error is there, right? Now, not having the disease, still positive means error is there, so 0.03. Okay, we're looking for PT, right? Probability of the test is positive. We'll have both the conditions for disease, having disease, not having disease. So write like this: probability of having the disease and testing positive. So PTD plus probability of not having the disease and testing positive. Check this out. Okay, what is this, sir? So they've given that probability of having the disease. Have a look. 1/2% of the population is having the disease, right? 1/2% means what? 0.5%, right? Means what? It's going to be 0.5%, right? It means what, bacha? So 0.005 is the probability. So what is the answer for not having the disease probability? 0.995. 0.995. Okay, so let's use these values over here. 0.005 multiplied with PTD. How much is that, sir? 0.98 plus not having the disease. So 0.995 into what is that, sir? 0.003. 0.003. Let's do the multiplication over here. What's my answer? If I multiply with 5, 9 8, so 8 5 is 40. I get a 0. So I have 4 carry. 9 5 is 45 plus 4, 49. Okay, 0.49. So I have how many places, bacha? 2 here, 3 here, 5, na? So 2 zeros over there. Then comes the decimal point. So 0.00490 plus. What about this? 5 3 is 15. So 5 carry 1, 9 3 is 27. 128 carry is 2. 9 3 is 27 plus 2 is 29. Correct, na? Repeat this. 5 3 is 15, carry is 1. 9 3 is 27, carry 1 is 28, carry is 2. 9 3 is 27 plus 2, 29. So right here 29. We have 3 here, 3 here, means total of 6 decimal places. So right here 4 already have 0.00282985. Okay, 2985. Let's add them. What is the answer going to be? PT will be given by sum of this, right? So I have 2, 4 and I have a 0 over here. Correct only, no? So I have 3 plus 2. So 3 and 2, 5 places only. So I have to make 6, right? 3 and 3, 6. Okay. So let's add them, bacha. I'm going to get last 2 as 5. 8 remains as it is. We have 9 and 9. So 8 carries 1. 2 and 3. 3 plus 4 is 7. Okay. One second. I think I have done a mistake in the addition part. Let me have a look. So what I'm getting bacha is coming as, okay, yeah, 0.995, okay, and 0.003. All right, 3% is 0. Okay, 0.03, no, 3%. Okay, 0.03, sir. Sorry, 0.03. Okay, this is not 0.03, 0.03. There was a mistake in over here. I've taken. Okay, so this will also change. 1 second, let me just make the change over here. 0.03. If I multiply this, I'm gonna get what, bacha? 5 decimal places, no? So I'll have here this here as 0.5 decimal places, right? So I'll have 0.02895, 2985, 0.2985. I took it as 0.03, okay? This has to be 0.03 only. I took double zero. So let's add it now. If I do that, I have 2, 4, and so I don't need extra 0 over here. I'll remove this part. Now I can add, right? So 3 to 5 and 3 to 5, that's correct. Let's add the picture. So 5 will remain as it is. 9 plus 8 is 17, carries 1. So 4 plus 9 is 13, plus 1 is 14. Okay, I have 1, we have 2 here. So 2 plus 1 is 3, then last is 0. Then I have 0.03475. Can I round it up? We have only 3 decimal places. So PT will be given by 0.03. Okay, 5 na, rounding it off. 7 4 will become 5 only, no, 4 7 is there, so I can round it off to third decimal place, will become 4, will become 5. So 0.035, option number B, bacha. Okay, forgive me for taking time in the calculation. I messed it up. I took it as 0.003. okay, 3%, right? 0.03 only, not 0.003. 3% is 0.03, sir. Okay, please make this change. This is your answer. 0.035 means the test has to come positive. Chances that Amit's test comes positive is this, including the error part as well. Means error we have also involved in our calculation. When we do that, the answer is coming as 0.035. I hope this is clear. Okay, let's move on to question number 6. A bag contains 3 white and 6 black balls, while another bag contains 6 white and 3 black balls. A bag is selected at random and a ball is drawn. Find the probability that the ball drawn is of black color. Okay, so we are looking for only total probability again. Probability that only black color ball is drawn. Okay, again we are not going to use Bayes theorem, only the total probability. Chaliye, let's have a look, bacha. So bag contains 3 white balls, 6 black balls. Okay, so again we can take, bacha, bag 1. E1 is picking from bag 1, from bag number 1, and event E2 is picking from, 1 second, from bag 2. 1 second, from bag number 2. Okay, E2 is picking from bag number 2. So we are looking for, but bacha, we are looking for this will be, sir, probability of picking bag number 1. Okay, are there identical bags? Yes, sir. Times, what is it? Probability of picking the black ball from bag number 1 plus probability of picking the bag number 2 times probability of picking the black ball from bag number 2. Correct now? How much is it going to be? 1 by 2, 1 by 2, right? 1 by 2 over here. Multiply this with picking the bag number 1. Half chances are there, right? 50%, 50%. So half black ball from the bag number 1. So have a look. 3 white, 6 black. So 6 by 9, right? Correct here. 3 white, 6 black. So 6 by 9. Okay. What about the bag number 2, bacha? So picking the bag number 2, again the chances is half. Okay. We have 3 black and 6 white. So 3 by 9. I can take 1 by 2 common, sir. I get here 6 plus 3 by 9. How much is that, sir? Simply 1 by 2, because 6 plus 3 is 9. They'll cancel each other. Chances is what? Picking a black ball is, what is chances? 1 by 2. Option number D is correct. Option number D is correct. Have a look. Option number D is correct, bacha. Simple problem. Okay, let's move on to question number 7. Given 3 identical boxes, 1, 2, 3, each containing 2 coins. In box 1, both coins are gold. In box 2, both are silver. And in box 3, there are 1 gold and 1 silver. A person chooses a box at random and takes out a coin. If the coin is of gold, what's the probability of that other coin in the box is also gold? Okay, chaliye, means basically what does it mean, bacha? It means that we have to choose which box, sir? Box number 1 only. Correct, na? How can you get both coins as gold? So first coin is gold, they've given that. What is the probability that other coin is also gold, sir? What it means, bacha? It means simply that it has to be chosen with box number 1 only. Okay, chali. So let's have a look what we can do over here, bacha. We can do here. So they're looking for probability of picking. So the box number 1, and it is of course gold, right? Of course it is gold, sir. Chali. So I have to define, bacha, the events, right? So let's define the event E1 for picking box number 1, okay, and event E2 for picking box number 2, and event E3 for the picking box number 3, okay, picking box number 3. So we are looking for this value, right? They're asking what? Probability that other coin is in the box also a gold. What it means? It means basically what I said, that it has to be box number 1 because it has both coins as gold only. Okay, so if you have to define this using the Bayes theorem, I'll get it like this: B E conditional G will be given by, check this out, PG E1 times PE1, okay, correct na, divided by all the 3 probabilities, right, for the box 1 and 2 and 3, 1, 2 and 3. So we'll come, bacha, the same thing will come over here, PG E1 times PE1 for the box with the gold, which is basically the gold box. Next one, bacha, what? It's going to be P gold from the second box, okay, and the last one gold from the third box, right? Chali. So let's have a look. What is this going to become? I have written it little bit incorrect. What is that? I can't write the equal to sign over here, bacha. I hope this is clear, right? Yes, sir. Equal to sign is like this, no? Okay. So if I'm writing this thing again, PE1 from, means gold is picked, no, from the box number 1 will be what, bacha? Have a look. What is this? Picking the boxes. Chances are half and 1 by 3, no? 3 boxes are there. I can pick 1 box at a time, no? 1 by 3 is a chance. For picking the first box, chances what, bacha? 1 by 3. Okay. And what is the event of this is 1 by 3? Gold from the box number 1. What it is, sir? Both of them are gold only, no? So chances are 1. Correct, right? I'll repeat. Gold from the box number 1. Gold from box number 1. Box 1 contains both gold, means chances are 1 by 3. Okay. What about picking the box 1? Sorry. Picking the gold from the box number 1, chances are what, 100%, so 1. Picking the box 1 is chances is what, 1 by 3. Same way, picking the box number 1, same thing will be written over here, 1 by 3 and 1 plus. From the box number 2, picking gold. Second box has both silver, picking gold, 0, sir. Picking the box 1 by 3. Correct, no? Second box, to pick the second box, answer is 1 by 3, and chances of picking the gold out of the second box 0 because there is no gold in the second box, both are silver they have given. Third box, picking the third box, bacha, 1 by 3 again, and picking a gold from there, 1 gold 1 silver means half, right? Correct, no? Don't worry, I'll write it over here again. So basically I'm saying this, probability of the event or picking the first box and both the coins are gold will be, bacha, what? Will be, first numerator will remain as it is, 1 by 3 only. 1 by 3 into 1 is 1 by 3 divided by, check this out, 1 by 3 into 1, 1 by 3. This will become what, bacha? This will become 0, na, sir? Because picking a gold out of second box, no chances, sir, so 0. Picking a gold out of third box, what's answer, bacha? 1 by 6. 1/3 chance to pick the third box and half chance to pick the gold from the third box. Because if you open the third box, you can pick the gold also, no, sorry, silver also, right? So half chances to pick the gold and 1 by 3 chance to pick the box number 3. So 1 by 6. Okay. Now I can simplify this. 1 by 3 I have over here. I can take this LCM, will become 6. 2 I have plus 1. Okay. So what I'm getting? 1 by 3 upon 3 by 6, right? So I can cancel this. 2 is coming. What is my answer? 1 by 3 divided by 1 by 2 gonna give me as 2 by 3. 2 by 3, sir, is my answer. 2 by 3, option number C is correct. Option number C is correct. 2 by 3 is my answer. Please have a look. I hope this part is clear. Bayes theorem. Okay, simple question. Okay, very simple. I hope you got it. Box 1, box 2, box 3. Box 1 has both gold. Box 2 has no gold. Box 3 has 1 gold, 1 silver. Okay, that's why box 2 condition becomes 0 bacha here. Okay, chaliye. So if you want, you could actually in exam you don't have to write all of this. I'm giving the steps because to make the simplified answer. Otherwise, you can just write this as answer. From the box number 1, picking gold. Picking the box 1 is what bacha? 1 by 3 chances, no? Picking the gold. Completely no, because both coins are there, so there are no chances as it is. So 1 by 3 directly. Same thing will come over here for the box 1, box 2, 0, box 3. Picking the box is 1 by 3 and gold is again 1 by 2. So 1 by 6. Product will be 1 by 6. Don't have to write all of this. Simply write this statement and get the answer. 2 by 3 is the answer. Question number 8. A bag contains n plus 1 coins. It is given that among n plus 1 coins, one coin has head on its both sides. Means there's a biased coin. We have a biased coin. Okay, we have a biased coin. Okay, one biased coin, sir. Whereas the rest of the coins are usual. So other coins are unbiased. Unbiased coin. How much is this? N. Because total is given as n plus 1. One is biased, other is n, which is unbiased coins. Okay. The coin is randomly selected and gets thrown. The probability of getting head. Probability of getting head. Okay. They're asking about bacha. pH is given here as 7 by 12. Okay. So think about it like this. Probability of head from both the coins, right? I have the chances for both the coins. From the first coin, sir, which is a biased coin. So what is the probability, bacha? Probability of getting a coin. I'm going to call this as, let's say, event E1, and this as event number E2. So getting probability of getting from the event E1, okay, and head from the event E1 plus probability of event E2 and head from event E2. 1 second. Head from the event E2. All right. Head from event E2. Okay. Now what I get over this? Please check. For event E1, probability of event E1 is what, bacha? It's going to be 1 out of total. Only 1 is the event E1, right? Unbiased coin. Sorry, biased coin is only 1, no? So only 1 out of what? Total n plus 1. Correct or not? We have only one such coin out of total, which is n plus 1. And what is the head chances of getting that? Both sides are head only, no? What is the chances? 100%, no? So 1. From the biased coin, which has both sides as head, I can get what, bacha? Head both the times, no? So 1. Whatever chances I took, it will always be 1, right? So 1. What about the event E2? Total number is what, bacha? N. So n upon n plus 1. Correct. Now total number of unbiased coin is what? N, sir. So n upon n plus 1. And what about the probability of getting head in that? It's unbiased coin, sir. Half, no? So check this, bacha. You can take n plus 1 common. 1 by n plus 1 common. What is this going to be? Have a look. We'll have n by 2, right? So it will become 2 plus n by 2. And this is equals to, they have given here, 7 by 12. I can solve this. 7 by 12 equals to n plus 2 by 2 times of n plus 1. 2 and this cancels. 6 I get. 7 times of n plus 1 cross multiplication. 1 second. 7 times of n plus 1 cross multiplication like this, and over here 6 times of n plus 2. 7n plus 7 equals to 6n plus 12. Bring this over here, bring this over there. I get 7n minus 6n. So n, 12 minus 7, so 5. What is my answer? N equals to 5. Option number C is correct. N equals to 5. Option number C is correct. Simple question. Looks very smart, but it is a very simple question. Please have a look. Okay. Now I'll move on to question number 9, sir. Got this, no? This is very easy. N equals to 5. Okay. Now question number 9. A person has undertaken a construction job. The probabilities are that there will be a strike, 0.65%, 65% chances there will be a strike. 0.80 that the construction job will be completed on time if there are no strike. okay, and 0.32% or 0.32 probability is there that construction will be completed even if there is a strike. What are they asking? Determine the probability that the construction job will be completed. So let's say probability of job to be completed is given by Pj, okay, they're asking us this value, bacha. So we have both the conditions, no? Probability of job can be completed in both the conditions, whether there's strike or not, okay. So whether there is a strike, the construction probability will be given by J with the strike, job with a strike, okay. What is job, sir? Job to be completed. J represents job to be completed, okay, plus probability that there is no strike and job is completed, and job is completed. That there is no strike and job is completed. First case is job is completed and there is a strike. Second is job completed and there is no strike, okay. Chances of strike, sir? Chance of strike is what, bacha? 0.65. Chance of strike is 0.65. Job completed by even then is what, bacha? 0.32. No strike, half subtract from 1, sir, so 0.35. Correct, na, bacha? Chance of strike is 0.65. No strike means what? 1 minus 0.65, okay. Chances of no strike, sir. 1 second. Chances of no strike, sir, will be given like this only, no? 1 minus chances of strike, how much is that? 1 minus 0.65, how much is that? 0.35, है ना? चलिए, so 0.35 times of probability of job getting completed even though there is no strike, okay. So what is that? 0.80. So 0.8 I can write simply, okay. So I can do what? I can take 0.8 common, sir, okay. How come, bacha? There is 0.42, no? What is 0.32? Sorry, not 42, 0.32. Nothing but 0.8 into 0.4. Not sure. 0.32. 1 second. 0.32 is given by 0.8 into 0.4. 8 for the 32. Correct, na? 0.4. So 8 into 4 is 32. 2 decimal places, so 0.32. So I'm going to write this only over here and take 0.8 common. Take this out. 0.8 is taken common. I have 0.65 left here. Into what, sir? What is left now? I've taken 0.8 common from 0.32. What is left now? 0.4, sir. Plus 0.35. Plus 0.35. Okay. Chaliye, let me continue over here now. What I'm getting, sir? Probability of job to be completed will be given by 0.8 times what I have inside. 5. Okay. So 5 4s are 20, carries 2. 6 4s are 24 plus 2 is 26. Correct, na? 5 4s are 20, carries 2. 6 4 24 plus 2 is 26. The 3 decimal places, so 0.26. Okay. The last one is 0.35. Add it. What I'm getting, bacha? 0.8 into, I'm getting here, sir, 6 plus 5 is 11. 3 2 is 5 and 1 is 6, right? 6 plus 5 is 11. We have nothing over here but 0. Okay. So 6 plus 5 is 11. 3 plus 2 is 5, 1 6, and there is decimal point. What I'm getting? Multiply this. So 0 I can ignore. So 8 1s are 8. 8 6 are 48. Okay. 48. We have, if I ignore the 0, bacha, I'm gonna get what, sir? I'm gonna get, 1 second. If I ignore the 0, sir, I'm gonna get total of 3 decimal places, right? So 0.488. 0.488 is my answer. Option number A is correct. Option number A is correct. 0.488 is the answer. Please have a look. I hope this is clear. Please have a look one last time. Okay. So with this, question number 9 is over. Now, question number 10. Question number 10, sir. 2/3 of the student in a class are boys and the rest are girls. It is known that the probability of a girl getting a first class is 0.25, which is 25%, and boy getting first class is 0.28, which is 28%. Find the probability of the student chosen at random will be getting a first class marks. Okay. Okay, sir. I've done this question, no? Something like this I've done a question, either 1 or 2, something like that. Please check. So answer would be option number C. I'm giving you the answer. Okay. So solve question number 10. This is going to be your homework. Okay. This is going to be your homework, sir. Option C is the right answer. I think 0.27. Please have a look. I've done a similar question. Okay. And you're going to comment that. You're going to got this. Got it right, sir. Question number 10. Which is the option, sir? Option number C. Please check. Please check. solve this and get me the comment, okay, that you got this right. Simple question, yes or no. I've done a question like this, similar question I've done with different values. That's why I'm giving you this as homework. Okay, now with this bacha, I'm gonna conclude the session. It was a fun session. Complete the chapter probability. I hope you had fun. Any doubt you have, let us know in the comment section. I'll try to get back with the solution, with the problems of the whatever problem you have. I'll get to the solution of that problem in the comment section only. Otherwise, this is it. Okay, I'll see you in the next session. Till then, you have to take care of yourself, keep working hard. The exams are nearby, okay, and you have to be positive, bacha. I know it's tiring, I know it's very exhausting, but you have to do it. There's no other choice. So I wish you all the best for all your hard work. Okay, result will come, don't worry about that. I wish you all the best for your hard work. Rest all will take care of itself. Just keep working hard. Okay, so with this positive note, I'm ending the session. I'll see you then. Take care. Bye bye.